Okay, so what we're going to do now is we're going to go ahead and combine our normal distribution with what we were talking about in chapter 1, chapter 2, section 1, and that's our standardized scores. So our z-scores, or standardized scores, were when I took the value, I subtracted the mean and divided by the standard deviation. And when we looked at the distribution of all the z-scores, we ended up with a mean of 0 and a standard deviation of 1. And that's what's happening now, is now we're taking a standard normal distribution. So I'm taking a normal distribution and I'm standardizing all the scores. So I'm making them all z-scores. And this time our mean is still 0 and our standard deviation is 1, but now we're becoming more powerful because now we know that 68% of our data should be within 1 standard deviation every way, and 95% of our data should be within 2 standard deviations, and 99.7% of our data should be within 3 standard deviations. And again, this is using those z-scores to help us work with that probability. And so the nice thing about z-scores is that probability is the same. So now we can start breaking that down into actual z-scores of 1.18. And I can find that probability, and I can use that for any distribution because any distribution could be turned into a standardized distribution. So that standard normal distribution. And so then this gives me more power for more probability to be calculated. So this is our standard normal table, and it lists z-scores. So this shows, okay, here is the z-score that I'm looking for. What's the probability that I have a z-score lower than that? So this is always looking at lower. If you need higher, then what you have to do is you're going to have to do 1 minus the probability that it's lower. And so that's what we're going to work on calculating today. Now, how do you find your z-score? Let's say we have a z-score, or we found that our value had a z-score of negative 1.83. Then what I look for is, this is where my z-scores are, and I'm giving you this packet in class, so don't worry about it. I'm going to look for the negative 1.8. And then for that 3, I look up here. And so I'm going to look at where those intersect, and that tells me the probability. So 0.0336. And so that's what we're going to practice using. There is also, so these have all of our negative z-scores, which should occur on this half of our curve. But there's also another table for the positive z-scores. So that's going to occur on this side. So we'd want probability from here down, or the percentage. Okay. So standard normal table. Usually we can use the empirical rule, but we have that table and we talked about that. And the table is called a z-table because it is a table of all z-scores. So we're looking at a problem where we're shading the appropriate region on the graph, and then we're going to use the table to find the area. So what's the probability, or what percentage of my values will have a z-score less than 0.58? So let's go ahead and label our graph. So 0 in the middle, and we go out by 1 standard deviation each time. And if I have a score that is, I'm looking for less than 0.58, I would estimate where positive 0.58 is, and I want to shade everything below. So it gives me a good idea if I'm making a mistake, because I can shade this and I think, oh wow, that's definitely more than half. So I know that my value should be more than half. And when they give us these values aren't actually in percentage form, they're as a proportion. So it's up to us to change it to a percentage. So now I'm going to look up a z-value of 0.58. So I'm going to go to 0.5. I'm going to go to the 0.08, and my little thing's in the way. And I'm going to look at where those intersect. And I get the proportion of 0.7190, which is a percentage of 71.9%. So we're getting a more exact percentage, much better than we got with the empirical rule. And so it's a more powerful that way, using this table. So on our next problem, we're going to do the same sort of idea. We're going to label our 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And I want to know what percentage of my scores, or probability, that I have a z-score less than negative 1.12. So I'm going to go to the negative side, negative 1.12. And so I can see that by my shading that my answer should definitely be less than half. So if for some reason I use the wrong side of the table, the positive table, so the negative side, then I kind of get an idea, oh, whoa, that doesn't look right. And so that's why they wanted you to draw the curve, so you kind of see what's going on and what you're looking for. So now I'm going to go ahead and look up that negative 1.1 and then 0.02. So where those coincide gives me a proportion of 0.1314, which is 13.14%. Of my values lie below that, or 13.14% chance that I would get a score in that area. Okay, so now we're going to go ahead and look at a z greater than 0.26. So we're going to label and I'm going to find 0.26, probably right about here, and I want it to be greater than. Now keep in mind that my table doesn't do greater than, my table only does less than. So if I really want to calculate this, I have to do 1 minus the part that I'm missing. So we're going to find the part that we're missing, which is less than 0.26. So 0.26. So I'm going to do 1 minus 0.6026. Which gives me a value of 0.3974, or 39.74%. Okay, so for our next one, 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And we're looking at greater than negative 1.58. So 1.58, and we want it to be greater than that. So because it's greater than, we're going to do 1 minus, move this out of the way again, the missing portion. Because our table only tells us less than, so if we want greater than, we do 1 minus the missing portion. So I'm going to look at negative 1.58. So 1 minus 0.0571. Which gives me 0.9429, or 94.29%. Of our values, or 94.29% chance of getting a value that high. Okay, so now we've done lower, we've done higher. Now we're going to look in between two regions. So now we're looking at a z-score between negative 1.19 so negative 1.19 and 0.26. So what percentage, what probability, all the same idea. And we're going to be going towards probability. Right now we're just looking at percentage values. So now I'm going to take this top one, because when I do the top value, it's going to give me everything below, but I'm going to subtract the part I'm missing. So I'm going to take the 0.26, 0.6026, and I'm going to subtract the part that I'm missing, the negative 1.19. So 0.1170. And that's going to give me 0.4856. So 48.56% of our values will lie in that region. Okay, so on the next one, we're going to do the same sort of thing. Negative 1, 1, 2, 3. I'm looking between 2.09 and negative 0.58. And we're wanting to calculate that. So I'm going to take the higher value, because that goes all the way down, and I'm going to subtract the part that I'm missing. So the 2.09, it's in the way again, is 0.9817, and I'm going to subtract that lower part, negative 0.58, so 0.2810. And keep in mind, the more you show your work, the better off you are, because if you just pulled a number off the table wrong, they can kind of work with your information and give you some partial credit. But if you don't show anything, if you don't show your curve, if you don't show your values that you're subtracting, they will dock you big time. And they'll say, I have no idea where this is coming from. They just pulled some numbers out of who knows where, and I can't give them any partial credit. So always taking time to show your work so you can get some partial credit. So this is about 70.07% of our scores, or a 70.07% chance of getting a score in that range. Okay, so we're almost there. We've talked about the z-scores, finding the proportion or the percentage of values in those certain ranges. Now we're going to talk about working backwards. So let's go to the next page. And now we are using the table to find a z-score. So if I'm looking at my 20th percentile, this is 20% below. Well, 20% as a proportion is 0.20. So I'm going to look in my table in the center part, and I'm going to find that percentage. So 0.20. And I don't find the exact value. I find two that are really close. So I know that when I'm looking at this, my z-score is going to be somewhere in here. And so I can do an approximately negative 0.8, and then I can go 4, or I could put 5, and I would be correct. Both would be approximately correct. Or I can kind of look in between. So I could do a 4, and then it's closest to the 4, so I went with that. And then maybe going 4, 1, or 4, 2. And again, because I put that approximately, because I'm using that table, it allows me to find that z-score. So now we're going to do the same thing, and we're going to find the 76th percentile. So 76% below. So I'm looking for a 0.76 on my table. And it looks like it would occur right in between these two values. And I would kind of estimate to decide which one looks closer. So this is definitely a 0.7. And is it a 0.70 or a 0.71? And I would probably put a 0.0 and then go closer to that 0.01. So maybe add a higher number like 8. Because again, we're just kind of estimating and we're trying to find the best value possible that would represent that. If you have a hard time estimating that, then just go with a 0.70 or a 0.71. And again, it's still technically correct by using the table. Okay, so now that we've gone over just z-scores using the table and all that, now we're going to look at where do we use this? So what kind of contextual problems, because in stats, everything's a word problem. Just about everything's a word problem. So we're going to see how we apply that. So in 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. Assume that the distribution of his first serves, of his first speeds is normal. So we're going to use a normal curve with a mean of 115 miles an hour and a standard deviation of 6 miles per hour. About what proportion of his first serves do you think would you expect to exceed 120 miles per hour? So usually with this type of problem, and you'll see this a lot more second semester, but we're trying to build up to it, we start looking at writing out what in the world is going on. So we know his first serve has a normal distribution. We know the mean is 115. The standard deviation is 6. And what we want to find is the percentage of serves that exceed 120 miles per hour. So it's just a real quick state. What's going on? What do we know? What's our plan? Well, the graph on the left is going to show our distribution with the area of interest shaded. So let's look. We have a mean of 115. And then we have a standard deviation of 6. So I'm going to go up 6 to 121, up 6 to 127, up 6 to 133, and then I'd go down 6 to 109, 103, and then 97. So now I want to know what percentage is it going to exceed 120. So I'm going to go find about 120. And I'm going to shade, and it's exceeding, so I want it to be faster than 120. And so I can kind of use my empirical rule to help me out here, but I've got the more powerful tool of our chart. So to use my chart, what I need to do is now I need to standardize my values. So I'm going to take my 120. I'm going to subtract my mean of 115. I'm going to divide by that standard deviation of 6. So it looks like I got 5 over 6, which is 0.83. So that's my z-score. So now I need to go to my table and find the z-score of 0.83. 0.83.7967. So from my table, I got that. And so now I'm going to go ahead and change that to percentage. So about what percent? Oh, wait, I did that wrong. That should actually be how much is lower. That's my missing part. So if I want the higher part, I actually have to do 1 minus 0.7967. So I have to do a little bit more work because I wasn't paying attention. Wonder how often that happens to people. So I subtract and I get 0.2033. What made me notice I did something wrong? I looked back at that graph and I was all like, whoa, 80% of my graph is not shaded. I know I did something wrong there. So then I looked back and I was like, oh, shaded above. So now we can use this to say about 20% of Nadal's first serves travel faster than 120 miles per hour. So now we're going to build off that idea, and we're going to look at, well, what proportion of his serves are between 100 and 110 miles per hour? So I still have that same graph. I've got that 115. I've got the 121. I've got the 127, the 133, 109, 103, and 97. And we want to know between 100 miles an hour and 110 miles an hour. So now I have to do two z-scores. I have to do one for the 100 and one for the 110. So now I'm going to go ahead and do 100 minus 115 divided by 6. And so that's going to give me negative 15 over 6. Which gives me a z-score of negative 2.5. Yeah, looks about right based on my graph. And then I can check my z-score, 110 minus 115 over 6. Gives me a negative 0.833. And I can use that then with my table to help me figure it out. So I should take because remember this is shaded below, so I take the highest value and I subtract the part that I don't want. So I'm going to take that negative 0.833 proportion, negative 0.83, 0.2033. And I'm going to subtract the part I don't want from the negative 2.5. .0062. Grab my handy dandy calculator. And that gives me 0.1971, which means about 19.7%, or you can even round it if you wanted to, or 20% are between 100 and 110 miles per hour. So way more powerful than the empirical rule, way more powerful than anything we've done so far, giving us a lot more information with the percentage of scores, and eventually going on to probability. What's the probability that Nadal would have a serve between 100 and 110 miles per hour? And so that's where we're starting to go with that. Okay, so next time we're going to talk about, okay, we've done the empirical rule, not as powerful. We've done the table, way more powerful. But our calculator will actually do a lot of this for us. So next time, make sure you have your calculator, and we will look at using our calculators to calculate these values.